The second phase is very easy. So next type of sorting is tree sort. A tree sort is a sorting algorithm that sorts numbers by making use of the properties of binary search. So, so a tree sort is going to use the property of binary search tree. Okay, whether previous search sort we have seen is that what heap sort, where we are going to use the binary tree. Binary tree. Same here in case of tree sort. Whenever say tree sort, we are going to use binary search tree property. So you know that binary search tree. Okay, binary search tree property we know very well that all the elements will be lesser than the root. Left subtree will be lesser than the root node. Right subtree will be greater than the root node. The algorithm first builds the binary search tree using the numbers to be sorted. So whatever the elements you are given, you are going to build a binary search tree. See, previous one we have seen binary tree. A heap sort uses binary tree property. Here, the tree sort uses binary search property, binary search tree property that you have to remember. Next, once it is you have built the tree, then you will call the in-order traversal. You know that we have seen three types of traversal: pre-order, in-order, post-order. The in-order traversal of a tree, in-order traversal of the binary search tree. Keep in mind, in-order traversal of the binary search tree will give the sorted order, sorted order of the elements. So this is the example I have shown. Okay, so example of tree. So this is binary search tree property. So from this tree, we can come to know that this tree is maintaining the binary search tree property by because all the elements are lesser than root node, and this is greater than root node. Okay, any node when you take it will satisfy the binary search tree property. That is okay, fine. Next, for the give, what are the elements is given? 100, 200, like that will be given. For something elements will be given. You have to build a tree. That's all. I didn't show the given array, input array. I didn't show directly. I take an example. Okay, if any input array is given, you build a tree, binary search tree. That's all. Next, then you have to call the in order traversal. So in order traversal, you know that what left root, left to root, right, that you know. So when I call the left to root right, so this is the final output. So it will be in sorted order, it will be in ascending order. So 10, then what, left root right, 10, 20, 30, then this is over, then I will go for the root element 100. So this what is happening here. Then the remaining 150, 200, 300. So it will be in sorted order. When you call the in order traversal, so it will be in sorted fashion only. So what is algorithm you are going to write? So this is very simple. I didn't take much time for this tree sorting. Why? Because we have seen tree algorithms previously in the third unit. Okay, that's why I'm not taking much time on this. You're going to build a tree. Okay, build a binary search tree. That's all. So what is the algorithm for this? Write insert function for binary search tree. So what is the insert function? The first phase is inserting elements into the tree. Inserting elements in the binary search tree such a way that you have to maintain the property of the binary search tree. Then call the functions. What is over? Once you build what, you will call the in-order traversal. No, second phase is what? Calling the in-order traversal. That's all. Call the function to visit the nodes of BST using in-order traversal. So this is the algorithm for uh, tree sorting. So when you take tree sorting, we are taking only the binary search tree. We are not considering about other types of tree. Say for sorting, we are taking binary search tree. Okay, fine. So next is the complexity of the tree sort. So what is the complexity? So we are taking best case and worst case. So inserting a number in a binary search tree takes order of n log time. See, we have to remember these what time complexities and all. So for the binary search tree, it takes what? Order of log n time. If it is the case, like if it is unbalanced binary search tree, the numbers are already sorted. Okay, if it is already sorted, it takes what? The worst case. The worst case is this scenario. So the complete binary search tree with n elements is built in n log time, and the binary tree is traversed in order of n time. So the total required for the tree sort is this one. The total required is order of n log. For the best case is order of n log n, and for the worst case is order of n square. It requires quadratic time for tree sorting in case of worst case complexity. In case of best case complexity, if it is like n log n. So this is what about tree sort. So far we have seen different types of sorting. It is coming under the internal sorting. Okay, external sorting. Okay, so far we have seen different types of sorting which comes under internal sorting. So where internal sorting is that we are sorting all the elements in the computer memory. Keep it in mind. Okay, so all the elements so far we are sorted in the computer memory. For such a case that we don't have enough memory, computer memory, nothing but the RAM, all the, if we have huge voluminous of data, if the voluminous of data is high, so we have to store the data in the secondary storage. Okay, in such a case what we have to do? So that type of sorting is called external sorting. If the elements are stored in the external storage, secondary storage, hard disk, okay, and you are going to sort those elements, sort those records in the external storage, that type of sorting is called external sorting. So external sorting is a sorting technique that can handle massive amounts of data in terms of GB, in terms of TB, terabyte. It is usually applied when the data being sorted does not fit into main memory. So if it's not fitting into main memory, that is called what? External sorting. Cost is high for access time from storage. What is the disadvantage over in the external sorting? Why? Because in case of internal sorting, the access time is very less. Okay, because all the elements are residing in the RAM itself, no issues. If it is like in the external hard disk, okay, anyhow we are going to do the sorting in the main memory only, but we will take what? But part of the element, part of the record from the external storage and sort it, and again we'll store back into the external storage. So when you access the elements or records in the external storage, it takes time. That is the disadvantage of the external sorting. So only sequential access allowed. Why? Because what is here sequential access? Sequential access is that in case of secondary storage or hard disk, only sequential access is possible. It's not random access, not possible. Okay, whether I can forward the what elements, which I can forward the elements, or I can go backward the elements. Okay, it is not possible to randomly access the elements in the secondary storage. Okay, this is the disadvantage in case of external sorting. So what are the phases during sorting? So distribution phase and merge phase. While doing the sorting in case of external sorting, we will consider two types of phases. One is distribution phase and then merge phase. And one more thing we have to consider, that this is the oldest type of sorting, where it is developed during 1950s. Developed during 1950s. It is mainly developed for tapes. So nowadays we are calling the external storage as hard disk. Previously, okay, in older days, they will call the external storage as what? Tape. Okay, so here we are mentioned as tape. So it has developed in 1950s itself to sort the elements in the external storage. They have developed the external sorting. So it is the best sorting for the elements which is residing in the secondary storage. So to sort the elements, I require what input tape as well as output tape, that I will tell in the next slide. So strings are divided into number of blocks and keep string as long as possible. Here strings nothing but for example I've given elements, for example 30, 40, 60, 22, for example 22 and 11. So these are the elements, or we can say as records. These are the records. I can say 30 is one record, 40 is one record, 60 is one record. So here 5 records. Okay, so here I say a set of items is called as strings. So the set of items is called, I have 2 items in a set, that is called as string, and again those set of items is called a run. So these are the keywords you have to remember in case of external sorting. What is run actually? A set of m items is called run. Okay, so I'm initially what I have to do while perform the external sorting, I have to divide the given records, okay, in possible numbers. So that dividing part, each and every divided part is called as strings or run. Okay, each run can have number of records. Here the record we can say as blocks. Okay, why? Because all the elements in the external storage is stored as what? In blocks. Okay, a block can be of size 100 MB or 200 MB. Okay, so all the elements are stored in the external storage as blocks. And one more point is that always try to minimize the block access. Why? Because we are going to collect the elements from the external storage to sort it, right? So always in my algorithm, what I write an algorithm always should be what? Minimize the block access. I should reduce the block access. So these are the things we have to consider when performing the external sorting. So this is the typical example for external sorting. Why we have used merge sort is that in the second phase we are going to use merge sort. In the second phase you are going to use merge sort. So this is external storage. Okay, you have elements in the external storage. You consider that each and everything is called as blocks or runs. For example, this is a run. Each and every block is called as a run. So I will collect one by one run. Okay, so this is an input from the external storage. Then I will combine, I'll sort. This is unsorted format, all are in unsorted format. Then I'll perform the sorted format. Then I'll what? Store it in the external storage. So this is how the external sorting works. Okay, anyhow we are going to do in the RAM only. It's meaning that without RAM we cannot perform. Okay, we are going to collect the what? Blocks from the external storage. For example, you are going to sort 1000 MB. 1000 MB, for example, you are going to sort, but your RAM size is limited to 500 MB. It's not possible, right? What will I do? I will collect only the 500 MB from the, I'll collect only 500 MB from the external storage. Then I'll do perform sorting. Then the sorted elements will be stored in the external storage. Then remaining 500 MB from the external storage is taken and stored in the RAM. Then I will perform this sorting. Then I again what? I will store it in the external storage. Then perform the merge sort. So this is what the sorting works. So we have to consider the algorithm for this. So constructing the runs. So we told that a run is nothing but a set of m items. Okay, so here tape 1 is nothing but tape 1, tape 2 is nothing but some blocks. For example, I am considering 4 tapes. In my algorithm, I am considering 4 tapes: tape 1, tape 2, tape 3, tape 4. Okay, so tape 1, see, all these tapes are, tape is nothing but the external hard disk. External hard disk. Tape 1 consists of the elements, I mean the records. Okay, tape 1 consists of the records. Okay, this tape 2, 3, 4 are all are empty. Okay, it's an empty space in the hard disk. We are going to use this remaining tapes for sorting. You're going to perform what remaining tapes for sorting. So if tape 1 is not finished, first of all, how it is working, we'll see. Algorithm works. If tape 1 is not finished, yes, now the tape, this is the given tape. So tape is the records, consisting of records. I'm going to sort it. Read m items if available from tape 1. My m items is that, for example, I consider that 3 items in a run. So my string, number of strings in a run is 3. So I consider that this 3 as what? One run. Consider the first 3. First 3 is the run. Consider some m items. Okay, I will collect that from the external sort, from the hard disk, from the tape 1, and sort them in the memory. So I'll collect this first run. Okay, first 3 consists of some records like 1, 5, 6. It consists of some records. I will collect this and place it in the RAM. So RAM is, for example, RAM is there. So RAM is there. Okay, so I will collect this first run and place it in the RAM. Then I will perform the sort. 1, 5, 6 is taken. 1, 5 here, it is in sorted order. Okay, let it be 2, 1, 5, 2. It is 1, 5, 2. Okay, taken, and I'll place them in the RAM. Then I'll perform a sorting. Once I perform the sort them in memory, then write them into the tape 3. Okay, write them into the tape 3. These 3 m items, I think these 3 m items are called what? Run. I told the m items, set of m items is run. Again, I'll place it in the tape 3. So tape 3 is what we told now, it is empty, right? It is free. This tape 1, tape 3 all are external hard disk, keep it in mind. So it has some space, right? So 152 is placed here. 1, 2, 5. Why? Because we sorted in the RAM. Then I place those things in the tape 3. Fine. Next, if tape 1 is not finished, yes, tape is not finished. For example, you consider like there are this many elements like 0, 11, 20, 30, like that is goes on. For example, you have 50. You have 50 in the last uh, of the last element. So write them to tape 3. Okay, it's finished. Then if tape 1 is not finished, yes, tape 1 is not finished. Next, I will take the next run. I'll take the next run. Next run is that nothing but a set of m items. The set of m items does not change. Always it will be 3 only. We can decide. Okay, either you are taking, and one more thing, the set of m items is nothing but blocks. So first block, second block, third block. So the run consists of 3 blocks. That's all. Run consists of 3 blocks, and n, capital N, for example, consider that n is the number of records. So here we have taken 100 records. For example, we have 100 records. We are going to sort 100 records, and I divided these 100 records into what equal partition. Consider that I'm considering that I'm going to divide based on 3 blocks. So b equal to 3. B equal to 3. So nothing but a run consists of 3 blocks or 3 strings. Okay, if tape 1 is not, yes, it is not finished, we will take the second run and bring it to the memory. I will bring it to the memory. Okay, then sort it, and I will write in the what, tape 4, right? Because tape 2, 3, 4 all free only. Okay, I'm using the what, taking as a temporary tape to store. So 152 next is order 10, 11, 12 I am taking. So what I will do, I'll perform sorting and place it in the tape 4. So like that I'll keep on do repeat steps 1 and 2. At one stage the tape 1 will be free. So when I perform the third run, I mean the when I take the third run from the tape 1, I will place it in the, when I, after sorting I'll place it in the tape 3 only. See, alternately I'll place, that's all. When I take the run fourth run, I'll collect from the tape 1, sort it in the RAM, then I'll place it in the tape 4. So alternately I'll place. That is what, at one stage what happens, the tape 1 will be empty. All the runs will be in the tape 3 and 4. Okay, next merging phase. Next what I will do, perform merging, what you have done in the merge sort, same thing we are going to do. Then we have to merge runs in tape 3 and 4 into tape 1. Once I merge, I will place it again in the tape 1 and 2. Okay, that I will show it diagrammatically. For with an example, I'll show it. TB2. So I am considering 4 tapes where TA1 and TA2 are input tapes. Okay, and TB1 and TB2 are output tapes. Okay, nothing but I'm mentioning A as input tape and B as output. Okay, so 2 input tapes and 2 output tapes. And TA1 consists of what? Unsorted elements, unsorted records. So this is the unsorted records. So I am how say I am considering each and everything as record. So far we are told about elements. Okay, here we are saying about records. For example, each and one record is said to be employee in a company. Like employee, for a single employee there will be more information. We can store in what, several fields. When you take any student information, I can have any number of fields like his address, okay, his phone number, like that. I can have many fields. So I am telling here each and everything is a record. Okay, so how many records are you having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I am having 14 records. So this is residing right now. It is residing in the tape A1. That is the input tape, first tape. So sorting of runs, how am I going to perform? Uh, for my algorithm, I am going to take B as 3. Nothing but 3 blocks in a run. 3 blocks in a run. What I told, I have to collect the first run. So first run is that what? 3 blocks. Okay, nothing but a string. It is a string. Here we call it as a run. I will collect from the tape 1 and sort in the memory. Again, I'll write into the, again I will write back into the external storage. Keep in mind, we are sorting in the internal storage only. Computer memory, RAM only we are sorting. Once sorted, I am writing in the TB1. Fine. Next, I will take the second run from the TA1, tape 1. Okay. Then I will sort it and store it in the, say it is in sorted fashion. I'll store in the TB2. Okay. Next, I will take 4, 9, 10. So it is almost sorted. Okay. Anyhow, we have to bring it to the internal storage. I have to sort it. Then I will again back it right into the TB1 only. So alternately, I'm placing. That's why I've shown the partition, red color line, bolded red color line. shown the partition. Next I'll take 6 45 36, that is the another run I'm collecting from the TA1. So once it is sorted, I will write back into the external storage TB2. Then remaining I have what? The last run is having only 2 records, no issues. I'll just collect it and sort it and write back into the TB1. So this is the sorting offense. Then I have to perform the uh, merging phase. So this is distributed. We are told 2 phases, right? One is distribution phase, second is merging phase. So this is run. I have distributed in the tapes, output tape. Then I have to perform the merging. See, how will I merge? I will collect first run from the TB1. I will collect the whole thing. First run from the TB1 and the first run from the TB2, and I will sort it. I'll sort. While sorting, I'm using merging. That's all. We have seen the merge sort algorithm. So this is one input. This is one unsorted array, and this is one unsorted. Consider that it is unsorted array. It is sorted. I'm going to merge these two. Okay. The resultant is that what? TB1 and TB2. The resultant sorted is stored in the TA1. Why? Because TA1 is free now. We have collected all the inputs. Now right now the TA1 and TA2 is free. We are not used the TA2. Okay. Here we are using. Now we are using. So how will you do merge phase? You know that 3 is this is one array, this is one array. I'll take the index, 0th index of the TB1. 3 is compared with 18. Okay, which is lesser? Then 3 is lesser. I will place 3. Then again what? Increment my I value. I have shown clearly in the merge sort. Then once the element is taken, I will increment the I value. So it goes to 17. 17 is compared with 18. Okay, whichever is lesser, 17 is lesser. Okay, I place the 17. Next, I is incremented, moves to the 29. So 29 is compared with 18. So 18 is lesser. So I placing here. Then I'll increment the J value. So J once, because 18 is copied, 18 is moved from the TB2. So I'll increment the J value. Okay, and moreover what 24 is compared with the 29. So like that this happens. We have seen the merge sort clearly. So the same thing it is working here. Same principle is done here. Instead of doing a single element, I'm taking it as a whole run. That's all. Next, I'll collect what? Second run from the TB1 and the TB2, and I'll collect these two run into the internal storage RAM. Then I'll perform sorting. Then again I'll get back right into the TA2. Here I'm using a TA2. Okay, TA2. Why? Because I'm storing in TA2. You cannot store it in TA1. Because why? Because I'm writing TA2 is that it is a buffer storage. All this TA1, TB1 and TB2 are buffer storage. Keep in mind. These are all buffers used. Okay, buffer tapes. So here I am writing into the TA2. Then I am taking the third run of TB1. Then I don't have third run in the TB2. Okay, so I'll just collect that only one run from the TB1 and sort it, and again I'll write into the TA1. See, alternately I'll do. Once it is completed, I'll go for this one. Once this is completed, I'll go for here because I don't have much elements. I have only 14 elements. Okay, so it is over. Next, what happened? What we have to do? Same thing. I will collect the first run. Now the first run is what? This one. First run from the TA1, TA2, sort it, and I'll write back into the TB1. So I'll collect these two elements, these two records, these two runs from the tapes and sort it in the internal storage. Then I'll get back right into the TB1, and level 11.3 happens like this. Okay, so TB1, TB2, and finally what will I do? I will perform the operation for sorting the final order. TB1 and TB2 is collected and sorted. Now the tape TA1 is the sorted tape. So this is how the algorithm works, external sorting algorithms. Here using the merge algorithm, merge sorting algorithm. So what is the cost for this? So what is the cost for what cost incurs for this? So how much passes it require? It takes n plus 1 plus log n divided by b. So it's nothing but this is the ceiling operator we are using, ceiling operator. Okay, so here n represents the number of records, given records. In our case it is 14. In our case it is 14. And what is the size you have taken for the run? 3. It's number of pages or number of blocks in a run. Okay, so like this you are calculating the number of passes required to do the sorting, and what is the cost is that the time complexity, you can say 2n into number of passes. And one more thing we are performing, that two-way merge sort or k-way merge sort. We can use either two-way merge sort or three-way merge sort, k-way merge sort. What is this two-way? I'll show you an example. For example, I can use let it be 5, 3, 2, 1, 0, 8, 11. Okay, like this is there. Like this is there. So here, in case of merge, what will I do? I will take the first element, 0th index of the first array and the 0th index of the second array. I'll perform. I'll take two elements, okay, to sort the algorithm. This is called two-way merge, two-way merge sort. If I'm taking three arrays, like 22, 33, 0, 0, 2, 5 is something is there. Some elements are there in the third array. So in case of three-way merge sort, I'm telling about three-way merge sort. I will take three arrays. I will consider three arrays. So 0th index of the first array, 0th index of the second array, 0th index of the third array. I will compare these 0th index of the all the arrays, 0th index of the all the arrays. Previously, I had taken two arrays only. That's why we call two-way array. So I had taken three elements, three arrays. So that's why it's called three-way merge sort. If it is like k-way merge sort, you are taking k arrays. K arrays. That's what k-way merge sort. So in case of external sorting, you are using the merge sort algorithm also. You can use any type of sorting in what? Uh, internal sorting. Is it okay? Fine.